Okay, so a particle moves along the x-axis so that any time y equals to 0, this position is given by tq minus 12t plus 5. Find the velocity of the particle at any time. Okay, so to find the velocity, it just basically means just take the derivative. So the derivative is 3t squared minus 12. Find the acceleration. The acceleration is the second derivative. Okay. Find all the values of t which the particle is at rest. The particle is at rest when the velocity is equal to 0. So we're going to have 3t squared equals to 12. Divide by 3, so we get 4. So t is going to be plus or minus 2. But because we're talking about time can only be positive. So at t equals to 2, it's going to be at rest. Find the speed of the particle when the acceleration is 0. Okay, so when the acceleration is 0, we're going to find the time. So that occurs when t equals to 0. Okay, so now we're going to find the velocity at 0. So 3 times 0 squared minus 12. Okay, so the velocity at 0 is negative 12. So therefore the speed when the acceleration is 0 is positive 12. In part E, if the particle is moving forward the origin or away from the origin when t equals 3, justify your answer. Okay, well, at t equals 3, we know that the velocity is going to be positive. It means it's moving to the right. So the velocity is positive, it's moving to the right. So it's moving away from the origin. Okay, so to find the derivative, we're going to use implicit. So we have to use the product rule. The derivative of e to the xy is e to the xy. The derivative of u would be the derivative of 1 times y plus prime. The derivative of u times v plus the derivative of v times u. That's n at minus 2y prime. Distribute. Okay, so anything with the y prime, stay on the left. Just factoring the y prime. Everything else, move to the right. Find the derivative. So my derivative tangent inverse of u is 1 over 1 plus u squared du. So u is x squared du my derivative is going to be 1 over 1 over 2 squared 1 over 1 squared over 4. Okay, so now we need to find common denominators. The common denominator is 4. Multiply by the reciprocal. And 2 will cancel. There's my derivative. Okay, so I'm going to use the product rule to find the derivative. The derivative of u is negative 3 e to the negative 3x. The derivative of v is negative sine of 5x times the derivative of the inside. So derivative of u v plus the derivative of v times u. We get 3 negative 3x e. Okay, so find the derivative of the inverse when x is 28. Okay, different ways we can do this. Since this is the inverse, that's my y value. So in order to do this, I need to find the x value. So I can do one or two things here. I can either factor this way, or I can use my calculator and see when y is equal to 28. Let's use our calculator. 5x squared minus 4x. So we're going to drop that. We're going to use our table to find when the y value is equal to 28. So when y is 28, x is 2. And I'm going to say I want x to be greater than 2. So you're going to have two values. If you go up, right, so x is greater than 2. So what we're going to do is we're going to take the derivative, to my x value, so the derivative of the y value, the inverse, equal to the reciprocal. Okay, so let g be the derivative of the inverse. We need to find the derivative of the inverse at y. Okay, so we know that when using this information right here, we know that when x is 5, y is 6. We also know that the derivative of my original function at x is 6. So therefore, the derivative of the inverse at 6 is going to be 1 over the reciprocal. Okay, so this one, find x is sine x. We haven't learned to use this. We can't use this, the derivative of this because A has to be a constant in order to use the formula. So what I'm going to do is I'm going to do implicit differentiation. What I'm going to do is I'm going to take the ln both sides, kind of a little trick. And the reason I do that is now I can move the sign of x using the properties of log. So if I take the derivative now, the derivative of ln of y is 1 over y, 1 over u, times the derivative of u. I'm going to have to use the product rule. The derivative of u times v plus derivative of v times u. So we have y prime is equal to cosine of x plus over x times y. Y equal to x sine of x. So we have sine of x, sine of x over x, sine of x. We could also find common denominators, make this a little bit simpler, but that's fine, we can leave it this way. Find the derivative of a. Okay, so we just have to use the formula. U is 3x, derivative of u is 3. So my derivative is going to be 1 over 1 plus u squared times the derivative of u. So there's a. B, again, I just have to use the formula. So u is e to the 2x du be 2 e to the 2. So the derivative of the inverse of secant is 1 over the absolute value of u times the square root of u squared plus 1 times the derivative of u. I can simplify this a little bit. Since e to the 2x will never be negative, I can take away the absolute value. 2 e to the 2x. These will cancel. My derivative is 2 square root of e to the 4x. See? Again, u x over 2. Du is the derivative. Again, 3 is just going to stay because it's a coefficient. I don't have to use the product rule. It would be negative 1 over square root of 1 minus u squared du. We're going to have negative 3 halves times 1 over square root of 1 minus x squared over 4. Okay, I can't leave it like this. I have to find common denominators. 4 minus x squared over 4. Take the square root of the top, square root of the bottom. Okay, so this 1 divided by this, it can be just times the reciprocal. My 2's cancel. And there's my derivative.